Hello and welcome to the tutorial on vector components. Now, the main rule here is that any vector can actually be written as the sum of a horizontal and a vertical vector. And to display that, we have a vector here, 8 meters per second, that is 30 degrees east of north. Now, when we show it as a triangle made from the sum of both the vertical here and the horizontal, it's going to make a triangle with a 60-degree angle on the inside here. Now, if we apply SOHCAHTOA, we can find both the height, or the y, which is sine theta opposite, because this is opposite, and the cos is the x, where we have x as the horizontal. Now, if we actually break this down and punch these numbers in our calculators, we'll get that the sine of 60 times 8 meters is going to equal 6.9 meters in the y direction, and the cos of 60 times 8 meters is going to equal 4 meters per second in the horizontal direction. Now, we're going to take this concept and we're going to apply it to a tension problem. So we have a mass here of 97 kilograms, which is suspended by two ropes, which are tied, and rope 1 is 48 degrees with reference to the ceiling, and rope 2 is 62 degrees with reference to the ceiling. Now, normally we would draw a triangle like such, where F equals the force of the mass acting down, and we would write that as the sum of T1 plus T2. But if we look here, we can actually split up the components of both of these tensions in the ropes, Y1, Y2, T1, and X1 and X2. We see we can actually add these up and get a resultant triangle from them. Now, because this weight isn't going anywhere down, we know that the vertical tension is going to have to equal the exact same tension being put on by this mass, which is 97 times 9.81. And because both of these are equal, we know that they can be both half of that. And when we type in 97 times 9.81, we get 962 approximately in our calculators. Divided by 2, we have a vertical tension in both of the ropes as 476 newtons. Right here and here. Now, what we can do is we can actually use SOHCAHTOA. Tan theta equals opposite over adjacent, more specifically, to solve for our x. We know that tan theta equals opposite over adjacent. In this case, we know that tan of 40 degrees is equal to 476 newtons over an unknown value, which is what we're going to solve for. And when you punch that into your calculator, you get 428 newtons for this one. So in T1, the horizontal component of this tension is 400. We're going to round to 429 newtons. So, and we'll do the same for the second one now, and we will get 476 divided by tan of 62 degrees, which is 253 newtons. Now, the tricky thing with vector components is we actually have to assign a positive and a negative direction. So we'll state that over here. We're going to say up as positive, and we're also going to say that right is positive. We'll indicate that with a plus sign up here. Now, because we designated right as positive, that makes this 429 newtons negative because it is actually acting in the western direction if we hold this true bearing. So, when we add these up, (253 minus 429) is equal to negative 176, or 176 newtons. So 6 newtons westward. Okay, so now we have a right-angled triangle in which we can apply Pythagorean theorem in order to get our hypotenuse. So, root of 952 squared plus 176 squared is going to give us our resultant. And when we do that math, 152 squared, we get a resultant of 968 newtons. Now, because this is a vector, it does need a direction, so we do have to find the angle in here, or this one, either one, to put this vector in reference to either the horizontal or vertical plane. So I'm going to stick with the horizontal plane here, and now I'm going to solve this with the sine law. So we can say that we can't do sine law actually because we don't know. Oh, yes, sorry. So yes, sine of 90 degrees over the opposite side length, which is now, we discovered, to be 968 newtons, over 968 is equal to, we'll call this angle theta, equal to sine theta all over another side length, which the opposite of this one would be 952. I do apologize for my rather horrific writing. It is really tricky to actually write on this. Okay, so now if we do the math here, you know that sine of 90 is actually 1, so 1 over 968 is equal to sine theta over 952. So if we multiply both sides by 952, and then inverse sine that, we will get that the angle here is actually 80 degrees. But we have to actually put that in reference to something, so we could say that this is the ceiling, this is 80, and this is 90, that's left with 10 degrees. So we have total tension of 968 newtons, 10 degrees from the ceiling. Alright, now, sorry about that. Now, the best way to utilize vector components, as a hint of advice, is during instances when you're adding up more than two vectors. Because if you are, it gets very confusing to use vector addition, and it's a lot harder to keep track of your angles. Whereas if you just break them down into components, you can just add several of them together to get a total, and you just have one triangle. But if you only have two, it is usually worth your time to just go ahead and do the question with vector addition, as it's a little bit more efficient. But thank you, and I hope you actually gained from this lesson. Enjoy.